it's information you're telling. So how will it look, that information? It will be in the form of waveform. Okay. So signal is any waveform that carries some useful information. Okay. So there are different definitions of signals. So I'll tell you one by one each one. So signals are the parameters that change with respect to time. Okay. They are the parameters that change with respect to time. Okay. They are single valued function of time. Okay. And they're represented as x of t or x of n. So I'll tell you the difference between these x of t and x of n. Okay. In some time. So can you name some signals around you which you have come across?
Electrical signal.
Yes, could you come again?
Electrical signal.
Yeah, electrical signal, video signal, audio signal, binary signal, voltage signals. These are some of the signals around you, right? Temperature signal, current signal. So these are some of the signals which you come across, right? So what is a system? What is a system? Could anyone tell what is a system? Like basic understanding, whatever you have understood, you can tell me. What is a system? What is a system?
More than one units working for a common purpose.
Yeah, it's a meaningful interconnection of physical devices and components. Okay, it's a meaningful interconnection of physical devices and components. So basically a system will have an input and output. Okay, you give input to a system and you get output. Okay, so what does the system do? It will accept the signal. Okay, it will give out another signal which is more desirable than the input signal. Okay, so systems basically accept inputs, they process the inputs and they'll give you the outputs. Okay, those outputs are more desirable than the inputs. Fine. So these systems will transform signals for various applications. Okay, so that applications class. Okay, so systems will accept signals, input signals. They process the input signals and give output signals which are more desirable than the input signals. Okay, so they might be used for many applications. Okay, so signal is a function which conveys information, right? So signal is a waveform which carries information, carries useful information. Okay, so we represent signal as x of t. Okay, here you have x. So just I'm taking it as x of t now. I'll explain you what is x of t and x of n in some time. So in x of t, you have dependent variable and independent variable. So x is the dependent variable and t is the independent variable. Okay, so the signals will represent some physical parameters that changes with respect to time. Okay, so the physical parameters might be your temperature, pressure, speed, voltage or current. Okay, so in this course the signal will be representing time varying voltage or time varying current. Okay, so your signal is something like time varying voltage, okay, or time varying current, but together will represent that as x of t. Fine. So your x of t, we represent a signal in the form of x of t. It might be voltage signal or current signal. Together we represent it as x of t. Okay, irrespective of its voltage or current. So here in x of t, you have x as an independent and t is an independent variable. Fine. So we shall see the classification of signals and we shall see in detail about systems. So coming to classification of signals. So first basic classification is continuous time signal and discrete time signal. And discrete time signal. What is continuous time signal? So we'll see that. And you have deterministic.
It's continuous.
Yeah, it is continuous with respect to time. Okay, it has amplitude for all the values of time. That is continuous time signal. Coming to discrete time signals, it is defined only for some discrete instance of time. Okay, so that is discrete time signal. Next, you have deterministic signal and random signal. So we shall see each signal in detail. Okay, next you have periodic signals and aperiodic or non-periodic signals. And we have even signals, odd signals. Next, we have energy and power signals. So basically, a signal in this course, you will be studying about both continuous time and discrete time. You will be solving problems on both continuous time signal and discrete. So continuous time signal we represent as x of t, whereas discrete we represent as x of n. Okay, so that is the difference. I will discuss in detail. Just I'm briefing up these classification. You have these different types of signals. So you will have problems on periodic signals, even odd signals, energy power signals. Okay, deterministic random, you have to know what is deterministic signal and what is random signal. Okay, and continuous time. So your problems will be both on continuous time and discrete time signals. Okay, you might have in the form of x of t or x of n. Okay. So that is about classification. We shall see this. Before that, we shall see about systems. Okay. So what is the definition of system? So a system has components which transforms or modifies an input signal. Okay. Input signals to produce some result. Okay. So could you name some of the systems which you have come across? So this is a system, right? So we give input to the system and we get output signal, which is more desirable than the input signal. Okay. So the signal produced by the system by processing the input signal are called as output signals. Okay. So systems are quite complex. Okay. They contain system components and signals of different types. So can you name few examples of systems?
Energy conversion systems.
Yeah.
Sound conversion.
Yes. Energy conversion, sound conversion. So I'll give you an example. You have an audio amplifier. So what does an audio amplifier contain? It contains microphone. So what does that microphone do? It will convert acoustic signals to electrical signals, right? So it amplifies that electrical signal. That electrical signal will be amplified, and it will convert that electrical signal, and it is given to a speaker, right? That speaker will convert electrical signals back to acoustic signal. So this is an example of signals and systems. Okay. Audio amplifier. Okay. So coming to system, you have continuous time system. Here we give x of t as input, continuous time signal, and you get y of t output, that is continuous time signal. Okay, so we can write x of t gives output y of t. Okay, you also have discrete time system. For discrete time system, the input should be discrete signal. Okay, discrete time system. Here the input is discrete x of n and output will be in the form of y of n, and we write x of n input signal gives you output signal y of n. Okay, and speech recognition system is one more system. Okay, and you have communication system. So what does this system contain? Speech recognition system. So you'll give speech to any system like voice. Suppose you'll give it to a computer and it will identify. Okay, it will tell you the identity of speaker. Right? This is one type of system, and you also have communication systems. So what does communication system consist of? What does communication system consist of? Can you remember the block diagram of communication system?
Modulators, demodulators.
That is for digital. Okay, normally speaking, you'll have information source, right? So what is the basic block of communication? You have a transmitter, right? Transmitter, you have a channel. What does transmitter do? It will convert, suppose you are sending a voice signal here. So the transmitter will convert that voice signal to the electrical form. Okay, it will convert to the form that is helpful for communication through the channel. Okay, it will convert voice to electrical signal transmitter, and it will be given to a channel. What is a channel? It is a medium through which your information will move, right? So it might be wired or wireless, optic fibers or any waves. Okay, so that is given to a receiving block, receiver. So receiver will receive your signal, electrical signal, and it will convert that electrical signal back to its original form, and you get the information. This is information destination, right? This is your basic communication system, right? So in channel, some amount of noise will be added. It will interfere with the interfere with the message signal, and it will be filtered out later using different techniques. Okay, this is about communication system. Have you come across control systems? Have you come across control system?
No, ma'am.
Okay, this is just introduction. Okay, I'll just brief up. I'll not go in detail to control system. So in control system, you'll have a block diagram like this. You have reference input. You have a summer here, and you have a controller, and you have a plant here, and that is given to one more summer, and you have here we have some disturbance. D of t, I'll name it, and you have actual output y of t, and you have a feedback here, that is a sensor. So that feedback signal is given here. Okay, so basically what is happening here is you have reference input x of t, assume it is x of t. Okay, so what is happening here? The output will be E of t. The output here at this stage will be E of t. You have feedback signal f of t given back as feedback to the input. You have a controller. Controller output is u of t, just for example, and you get actual output y of t. So basically what is happening here is you have a plant. So what is that plant? Is nothing but mathematical operations takes place here in plant. Okay, that will generate some output y of t in response to the plant input v of t or u of t. Fine. So you get output. So you have sensors in the feedback loop, right? So it will measure the plant output and converts it into another form, that is feedback signal. So that feedback signal is compared with the input signal x of t, and some error message will be generated, error signal will be generated. So that error signal is applied to the controller, okay, that will produce an actuating signal u of t, and that performs the controlling action of the plant. Okay, this is the control system, just some information for about systems. Okay, so you'll be studying this in detail, so no need to worry just much about this. So you have different types of systems. Okay, so you have speech recognition system, communication system, control systems, so audio amplifier. These are all some examples of system. Okay, and you have automobile steering control system. So if you want more information, you can just check out these. Okay, you have remote sensing system. Okay, these are some of the examples of your systems. Okay, so we have understood what is a signal and what is a system, right? So signal is basically a waveform which carries useful information, right? And what does a system do? It will accept the input signals, whichever you want to process the input. So its system will accept that input signal, and it will give you output signal which is more desirable than the input signal. Okay, so you have different types of systems and different types of signals. So we shall continue this classification of signal now. Okay, so this is our actual topic. So till now whatever we have discussed is your introduction. So we shall start with classification of signals. So the first classification we shall see is continuous time and discrete time signals. Okay, continuous time signal and discrete time signal. So you people know that continuous time signal is represented as x of t and discrete time signal as x of n. So we shall see what is continuous time signal. So this is x of t. Okay, this is time axis. So this is my signal, some random signal. So this is continuous signal. So why we call it continuous time signal is this has amplitude for all the values of time. Okay, from minus infinity to infinity, you can get the amplitude of that signal at any particular time. Okay, so it is continuous and you have amplitude at all the values of time. Suppose I can get it as time t 1 second, 2 second, 2.02, 2.5, like that. You can define the amplitude of this signal at any point of time from minus infinity to infinity. That is continuous time signals. Okay, so amplitude varies continuous with respect to time. Okay, so continuous time signals are naturally occurring signals. Okay, like can you name some continuous time signals?
Sine wave.
Yeah, that is continuous time signal. Yes, then any real world examples?
Audio signals, no?
Audio signals, yes.
And all analog signals are continuous time signals, right?
Yes, analog signals are continuous time signals, right? They occur naturally. Okay, like your heartbeat, right? Your heartbeat is a continuous time signal, right? Even you have acoustic signals, sound signals, speech signals, music, all are continuous time signals. Okay, so this your heartbeat or some any signal like that, you convert it into electrical signal using a transducer, right? So these are continuous time signals. So commonly available signals in physical world are all continuous time signals. Okay, so that is about this. Coming to discrete time signals, it is defined only for discrete values of time or discrete instance of time. Okay, it is defined only for some instance of time or discrete values of time. So I'll write like this: x of n is equal to 0, 1, 2, 1, 0, 3, 5. I can give some discrete values of time. So if I give a signal like this, how will you plot this? You need to know what is at time t is equal to 0, what is a signal, and time t is equal to 1, t is equal to -1. So these are present only at discrete intervals of time. Okay, they are not present for point values. Okay, they are only present for integer values of time. Okay, so I can write it as 1, 2, 3, 4, -1, -2, -3, etc. Fine. So if I write a signal x of n is equal to 0, 1, 2, 1, 0, 3, 5, something like this. So I have to, you people, if I tell you to plot, how will you plot this? You cannot plot randomly, right? So you have to know where is the origin. Suppose I'll give origin like this. So that means this is at n is equal to 0. This is at -1. This is at +1. This is +2. This is +3. This is at -1, -2, -3. So it means that at n is equal to 0, the signal amplitude is 1. At 1, it is 0. At 2, it is 3. At 3, it is 5. At -1, it is 2. At -2, it is 1. And at 3, it is 0. Got it? Did you follow? So discrete time signals are represented as sequence of numbers, and you need to know where is the origin. Okay, that represents 0. So at 0, the signal value is 1, and at 1, the signal value is 0. At 2, the signal value is 3. At 3, the signal value is 5. Okay, understood? So you can represent these discrete time signals as x of 0, x of 1, so x of 2, x of 3, x of -1, x of -2, x of -3, so on. Clear? So continuous time signals are specified for every value of time. Okay, and you represent it as x of t. Here x is your dependent variable and t is your independent variable. Similarly, you have for discrete, it is present only for discrete instance of time. Okay, so here x is the dependent variable and n is the independent variable.
Ma'am, radio signals come into category of continuous or discrete, ma'am?
Continuous.
Ma'am, but at a specific tuning only the radio frequency signals will produce, right?
So
Not
what
at
you
all
do, radio signals are continuous time signals. Okay, so processing will take place. Analog to digital form you convert, right?
Yes, ma'am.
Yeah, so conversion takes place there. Okay, so that is about continuous and discrete. So discrete signal will exist for fixed instance of time. Okay, it is represented by sequence of numbers. This you have to know. So most of the physical signals are continuous time signals, but the storage of those signals, storage of continuous time signal, processing and controlling these continuous time signals is performed in digital domain. Okay, that is about the classification of continuous time and discrete time. So in this course, you will be analyzing both continuous time signals and discrete time signals, both with a specific signal. Okay, so you might have continuous time and discrete time, both you have to analyze for everything. Okay, we are analyzing continuous time and discrete both. Okay, that is about continuous time and discrete time signals. So next classification is periodic and non-periodic signals. Okay, periodic and non-periodic signals. So what is periodic signal? What is periodic signal?
which occurs at particular time.
Which repeats, ma'am.
It will not occur at particular time. It will repeat at equal instance of time. Okay. So a signal is said to be periodic signal if it repeats at equal intervals of time. If it repeats at equal instance of time. So I will take an example of a sine wave. Okay, some x of t, this is x of t and this is time. So this is a sine wave. So this, what is the period of this? I'll take 0, pi, 2 pi, 3 pi, 4 pi. So what is the period of this signal? What is the fundamental period? So what is one cycle here? What is one cycle? So from 0 to pi, it is one cycle.
0 to 2.
Yes, someone has any doubt? Rakshita, you have anything?
No, ma'am.
So from 0 to 2 pi, you have one cycle. Okay, so what is the period of this? Period is 2 pi, right? So time period is 2 pi. So after 2 pi, it is repeating again with the same sequence, as you can see. Okay, again from 4 pi to 6 pi, it's repeating. So if a signal repeats at equal instance of time, that is called periodic signal. So I'll give you some example of non-periodic signal. What about this? It's periodic or non-periodic? It's non-periodic because it's not repeating at equal instance of time. So this is fixed signal. You have from -1 to +1, you have a signal, that's all. It's not repeating. Okay, what about this?
Periodic.
It's periodic signal. Okay, so because you have
Periodic.
0 here, 1, 2, 3, so on. Here you have minus. So what is the period of this signal?
One, ma'am.
How one?
Two.
2, ma'am.
Period is 2, right? See here. Here you have a signal here. In between, you take it as reference. Again, till here, you'll have one period. Or you take from minus 0.5 to 1.5. So this is one cycle. Okay. So I'll take this as minus 0.5 to 1.5. That is one cycle. So what is the period? It's 2. Or you can take it from 0 to 2. So your signal is here. It is like this. It is repeating itself at equal intervals of the time, like repeating the same pattern. Okay, so till here. So what is the distance interval for one cycle? It is 2 seconds, right? So the time period is 2 here. Fine. So the time period for such signal is 2. You have to analyze, like, so what is the pattern and what is the pattern repeating? So you'll get to know what is the period. Fine. So we shall see the definition of periodic signal. So a signal is said to be periodic if x of t is equal to x of t plus capital T for all t. Okay. So the minimum value of t for which the above this statement is valid is called as fundamental period. Okay, what did you understand from this? If x of t is equal to x of t plus capital T, here your capital T is the minimum value of time period. Okay, it is called as fundamental period. So if this equation is not satisfied, if this equation is satisfied, it is called as periodic signals. Okay, for all t, time instance t. So if this equation is satisfied, it's periodic. If this equation is not satisfied, it is called as non-periodic signals. So suppose I have delta t, some as 5 seconds. Okay, so my x of t is equal to x of t plus 5. So this is called as fundamental period, 5 seconds. So x of t is equal to x of t plus 5. So next cycle what I have x of t plus 5, which is equal to x of t plus 10. So this goes on. Here I have x of t plus n minus 1 into 5, which is equal to x of t plus n into 5. Okay, so these are, so I can write it in the form x of t plus n into t. Okay, so this t is called as fundamental period. Fine, suppose you have a sine wave. For example, I'll just take a simple wave, sine wave. So this is your x of t. So you have pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So here my time instants are pi, 2 pi, 3 pi, 4 pi, so on. So I can write sine theta as sine theta plus or minus n into 2 pi, because 2 pi is one time period. My time period is, fundamental period is 2 pi. So I can write, if n is equal to 2, what happens to this? Sine theta is equal to sine theta plus or minus 4 pi, right? If n is equal to 2, so 2 into 2 pi, you will get 4 pi. So if n is equal to 3, you will get sine theta or x of t as sine theta plus or minus 6 pi, so on. So the signal is periodic. Okay, so it is repeating itself after equal intervals of time. Okay, this is called as periodic signal. So a continuous time signal is said to be periodic if it satisfies this condition, x of t is equal to x of t plus capital T for all the values of t. So capital T is called fundamental period. So what is the fundamental period? It is the time taken by the signal to complete one cycle. Okay, it is a time taken by your signal x of t to complete one cycle. Okay, so I'll take t as, you people know that t is equal to 1 by f, time period is equal to reciprocal of frequency, or frequency is equal to 1 by t. So what is angular frequency omega? What is omega? Equal to
2 pi f.
2 pi f. So I can write omega as 2 pi by t also, right? So omega is called angular frequency. Its unit is radians per second. Okay. So any continuous time signal which does not satisfy this equation is called as non-periodic signals. Okay. So this is with respect to continuous time signals. We shall see about discrete time signals. Similarly, for discrete time signals, you have a statement x of n is said to be periodic if it satisfies the condition x of n is equal to x of n plus capital N. Okay, where for all the values of n. So your capital N here is called sample, okay, or fundamental. Okay, it is a positive integer. Okay, so the smallest value of n which satisfies this equation is called fundamental period of x of n. Okay, so here and in continuous time we'll take angular frequency as omega like this, whereas in discrete time we'll take it as omega like this. Okay, you have to observe this difference. In continuous time, we take omega is like in the form of W. Here we take omega like this. Both are omega only. In continuous time, you take omega like this, whereas in discrete time, you take omega like this. So here omega is equal to 2 pi by n. Okay, clear? So any discrete time signal which does not satisfy this condition is called as non-periodic or aperiodic discrete signal. Clear? Is it clear for you? So discrete periodic signal I will draw and show you. So we have x of n. Okay, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, so on. Here also I have -1, -2, -3, -4, -5, so on. So I'll draw the discrete periodic signal, just have a look. So here the amplitude is 1, whereas here it is at 3 the amplitude is -1. Okay, again at 6 the amplitude, here you have -1 amplitude, again at 6 the amplitude is 1. Okay, it goes on like this. Now can you tell me what is the period of this signal?
Five.
Tell correctly, how much is the period?
6, ma'am.
Time period is equal to 6. Okay, fundamental period is equal to 6, because after 6 samples the waveform is repeating itself, right? So the time period is 6. So I'll give you one more example for non-periodic signals, non-periodic discrete signals. Suppose you have x of n. So you have 1 here, amplitude 1. Next you have 0.5, 0.25, 0.1, so on. This is discrete non-periodic signals. Okay, non-periodic discrete time signal, whereas this is periodic discrete time signals. Okay, so what about exponential signal? Oh, so this is exponential signal. Okay, fine. Here for continuous time signal, you can take an example for non-periodic as exponential also. This is periodic signal, right? Sine wave. So this is non-periodic continuous time signal, x of t. Non-periodic continuous time signal. Or you can take just a waveform like this. Or you can also take like this. So these are some non-periodic signals. Okay, if you have like this, it is periodic. If the waveform repeats itself at equal intervals of time, then it is called as periodic. If it doesn't repeat, if it has only one cycle, it is non-periodic. Okay. So that, did you follow periodic and non-periodic signals?
Yes,
Ma'am,
ma'am.
can you explain discrete signal again?
Yeah. So discrete signal.
Like how, ma'am, what is the use of 2 pi by n, ma'am, there?
Here, omega, that is omega, discrete. For discrete time signal, see, for continuous time signal, omega, you represent omega in the form of this, W, whereas in discrete time, you represent it as omega like this. For continuous time, so in periodic, non-periodic signals, you have problems, they'll ask you to find out whether the signal is periodic or non-periodic. If it's periodic, then find a time period, they'll ask you. You have to find a time period t or n. With respect to continuous time signals, you have to find the time period t. With respect to discrete, you have to find the n. Okay. So here omega we represent as 2 pi f in continuous time signals. So omega is equal to 2 pi by t, because frequency is equal to 1 by t, right? So we take W is equal to, that's omega is equal to 2 pi by t in case of continuous time. In case of discrete time, you represent omega like this shape, Okay. So that will be equal to 2 pi by n. It is similar to this one. 2 pi by t you have here. Instead of that, you have 2 pi by n here. What is t here? Time period. Here n is the number of samples or time period for discrete time signals. This is time period for continuous time signals. Clear?
Yes, ma'am. And ma'am, how their time period is 6, ma'am, in the example which you have taken?
See, so my signals are from, so what is the time from 0 to 5, right? So you have a signal at 0, a signal at 1, 2, 3, 4 and 5. So how many samples you have here? 6, right? So time
Yes,
period
ma'am.
is 6. Okay, sorry, you should have n here instead of t. So in continuous time you represent it as t, whereas discrete time you tell it as samples, n.
Ma'am, but then you have also taken 6, 7, 8 and 9, no? Why
See,
we are
yeah.
not considering that, ma'am?
See, after 6, this is one cycle, correct?
Yes, ma'am.
After this cycle, again this pattern is repeating. 1 and minus 1. 1, 1, 1, minus 1, minus 1, minus 1. Correct?
Yes, ma'am.
It goes
Yes.
on. So this is repeating, right? At 6, it is repeating. Again, this pattern is repeating here. Till 5, you have one cycle. Again, from 6 to 11, you have one pattern, right?
Yes, ma'am. That is +1 and -1.
Yeah. So this is a sample here. Suppose I'll show you in the form of continuous time signal x of t. You have something like this. So what is a one cycle here? From 0 to 2, right?
1.
0
Yeah,
to
0
2
to
is one cycle. From
Yes,
again
ma'am.
from 2 to 4 is one more cycle. Correct?
Okay.
Similar to
Yes,
this. This is discrete time, this is continuous time. Got it?
Okay, ma'am.
Shall we solve one problem on
Yes, ma'am.
periodic, non-periodic?
Ma'am, next class.
Next class. Okay, I'll take the attendance. Just a minute. Just to verify this list, okay? If your names are there or not, I'll just call out. You just tell present, okay? Vinay? Vinay Kumar KV? Not there? Vinayak Rao?
Yes, ma'am.
Vishal?
Present, ma'am.
Yash?
Present, ma'am.
Yashas Kumar GB?
Present, ma'am.
Yashwant? Yashwant not there. Zenith? Not there. Zilvayu?
Yes, ma'am.
Srishti?
Present, ma'am.
Sohan?
Present, ma'am.
Tejas? Tejas is there. Vijay? Absent. Vijay Hegde?
Yes, ma'am. Ma'am,
You are
present,
there or
ma'am.
not? Have you on the
I am there, ma'am.
recording and you are doing whatever you want in the back end? You're there?
No, ma'am. I answered, ma'am, today.
Vilohit? Vilohit is there? Not there. Vinamrata?
Present, ma'am.
Vineet? Vineet?
Vinay Kumar is present, ma'am. My mic is not working in laptop.
Vineet A is there? Vineet M? Abhishek is there. Ajay?
Ma'am, Abhishek present.
Present, ma'am.
Ajay
Ma'am, Vinay
Lokesh?
Kumar is present.
Yeah, present, ma'am.
Akash Bharadwaj?
Present, ma'am.
Kulsum?
Present, ma'am.
Maithili? Maithili? Maithili is not there. Rushingwa?
Yes, ma'am.
Satvik? Satvik absent. Shashank,
Present, ma'am.
Srijani,
Yes, ma'am.
Dilsha Ahmed, absent. Ajay Desai, Gils Paul, absent. Rohit
Excuse me.
Adhikari,
Present, ma'am.
Gils there.
No, ma'am. Rohit present, ma'am.
Rohit present. Okay. Vivek,
Yes, ma'am.
Ritik Shah,
Present, ma'am.
Rahul Dinesh,
Present, ma'am.
Bharat Arvi,
Present, ma'am.
Bhavika,
Yes, ma'am.
Vaishnavi, absent. Ahalya,
Present, ma'am.
Manjunath. Manjunath is there. Can anyone confirm?
Yes, ma'am. Vinay Kumar.
Ma'am, Satvik present, ma'am.
You didn't answer when I called you out, right?
Ma'am, Vinay Kumar present. My mic not
Ma'am,
working in laptop.
Ma'am, Yashwant present, ma'am. 186.
What were you doing when I called your names?
Ma'am, Wi-Fi connection lost of hostel because of electricity not there. So got connection lost.
Vinay is there.
Yes, ma'am. Present.
Manjunath,
Ma'am is there.
Veena KV. Veena absent. Rakshita, Kiran,
Present, ma'am.
Akshay,
Present, ma'am.
Hanumanta not there. Girish Kumar,
Present, ma'am.
Pavan Kumar,
Present, ma'am.
Sumalata,
Present, ma'am.
Mamata Shri,
Present, ma'am.
Praveen,
Present.
Nikita,
Present, ma'am.
Mohan,
Present, ma'am.
Chetana,
Present, ma'am.
Kiran Kumar,
Present, ma'am.
Gautam, Okay guys, we can wind up this session. Everyone's name, did I call out? Did I leave anyone's name? Okay guys, we can wind up this class. Thank you.
Thank you, ma'am. Thank you, ma'am.